All right. So once again, here's a projectile. It's going to be at some angle now. So you are going to have some initial velocity along y. It's not going to be just like a straight up horizontal type of thing or anything like that. And I'm going to make an origin for my problem. You can make an origin wherever you like, but for me, I'm going to make my origin right here because it's going to be easier for me when I measure. So basically, it's the point on the ground. It's literally where I have my tape measure right here. It's the point on the ground that's just below the projectile launcher. That's where I recommend you put it because it's going to be easier for you to measure certain things. But it's up to you how you guys want to do it when you do your calculation. Typically, we would make when it launches our initial moment. So when it launches our initial moment. Sometimes if you want to say find out this is similar to your guys' airball thing that you did. Where you wanted to calculate, you wanted to calculate the maximum height, you had to make your final position something different than if you wanted to calculate your initial velocity, where you'd have to make your final moment somewhere else. So we could, for example, if we wanted to find out the maximum distance, we could make our final moment here. Or if we, if I say wanted to find out how fast it was going when it's back at the same elevation as before, I could make my final moment here. Or if I just wanted to find out, how high it was or how fast it was going at just some random point, like there, I could pick my final moment there. Or I could pick a final moment as this special case scenario up here, where it's at its maximum height. So I could say that the final moment is at that maximum height right there. And that is what I'm going to say, because I want to find out where am I going to, so I got a hoop here. Where would I need to place the hoop in order to, in order for the marble to go through my hoop? At the maximum height, yeah. So, but I want to find out where I need to be standing. So, I would call, so let's see. So for here, my initial height would be this. That'd be my initial position of the marble. My final position would be, of course, that's the final vertical position right there. I could have an initial horizontal position as being that point right there. The initial horizontal position is just 0. And then the final horizontal position, which that's also something I would be looking for. So with that in mind, what do I know? So you can fill out, right? These are the only variables you don't know. This still works out. Boy via and Zavikson? I don't know. Zavikson? Hugs and kisses. That works. So what do I know? What could I fill in here that I definitely know right now?
Acceleration.
The acceleration is what?
Negative
10 meters per second squared. Except we're going to solve this variably. So I'm going to call this negative g. Negative big G. Yeah. And I can plug things in later. So negative g. What else do I know or can I measure? Again, I can measure the speed. X naught, X, X, the initial position. Yeah, what's the initial position? It's 0. What else do I know or can I measure?
Y.
Why not?
Yes.
Yeah, why not? So we'll call it h naught, the initial height. Yo. Coolio. Thanks. So good. Oh my god.
Wait, what the heck?
Exactly.
Still have that to
Put the thing on so I don't get distracted.
What else do I know? Yeah.
Vy is 0.
Vy is 0. Yeah, right? It's at the top of that peak there. The velocity along y is 0. Is the total velocity though 0 up there? No, because there's still some x component moving to the right. So the total velocity is still that way. But at that moment, the y components are changing direction from going up to going down. So, and there's a part in there that's 0. And that's what's nice about choosing that moment right there, because I know the velocity there is 0, and I can solve for things there. All right, so I'm looking for x, the horizontal position, and the final position along y, the vertical position. So what about v naught y and vx? So like I said before, you can measure the speed. That is something you can do. What else could you measure? Okay, I'll give you a hint. If I measured the speed, let's say I got like, 10 meters per second. Which one gets 10? Does this one get 10 meters per second? Or does this one get 10? Or do both get 10? Neither get 10, right? Because this is how much the velocity is moving to the right. This is how much the velocity is moving up. And if the velocity is 10 meters per second, that ain't gonna fly. So what we gotta do is break up. So here's the initial velocity. Here's the vector. Oh, I got 30 degrees right now. We're not gonna do 30 degrees. We're just gonna say it's at some angle theta. So the thing is that if it's going at 10 meters per second this way, some of it is going this way, and some of it is going this way. So we want to figure out how much is this way, how much is that way. We're going to resolve this vector into its components. So the x components I'll do in red, and then the y components I'll do in blue. For the y components, we tend to say v naught y, because the velocity along y changes. The velocity along x through a projectile, does it change? No, it does not. So we're just going to call it vx. What I'd like you to do is theta something we could measure. Yes, in fact, this thing's got a degree thing that we can change those right there. So let's see. Theta is something we can measure. So I would like you, in terms of v naught, this v naught, and theta, calculate for me v naught y and vx. Please. Yeah. Okay. Anybody need more time with this? Raise your hand if you need more time calculating. Okay. Not a couple. I'll give you like 30 seconds.
Yeah.
Wait.
No. Sine theta should be.
Oh shoot, wait,
Opposite over.
I don't know how to 8 out of school.
No. You can't.
So what would you use? What would you use for v naught y? What trig function? Sine. So we're going to say sine of theta equals the opposite, which is v naught y, over the hypotenuse, which is v naught. So multiply both sides by v naught, I get v naught sine theta equals v naught y. So that's what I'm going to use for v naught y. And then v naught x, you would use a trig function of cosine of theta equals, so that's vx over v naught. That's the adjacent over the hypotenuse. Multiply both sides by v naught, you get v naught cosine theta equals vx. And then that's what I'm going to use for my v naught, for my vx. So I can plug those in over there. So it's going to be v naught cosine theta. And then this is going to be v naught sine theta. Now, our goal here is to calculate, we want to try and find out, so we're going to say we can measure the initial speed, because that thing can do it. We're going to measure the angle, because we know the angle. We know baby g. Can we measure the height of how high up this is? Is that possible? Yes, we could, walk up, grab one of these suckers, and, as long as we do it right? Okay. And we know the velocity right there is 0. So we're going to try and calculate in terms of all of these things. So if I got my solution then in all those things, I can then, do these measurements, plug those things in, and boom, there we go. What do you guys want to try and go for first? The horizontal position or the vertical position?
Vertical.
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 Who wants horizontal? Raise your hand for horizontal.
You have to
Raise your hand for vertical. Okay, holy crap, vertical, we're getting fine. So, what would you, no, go calculate. Go, figure it out.
Okay.
Figure out the vertical position. This one's kind of one equation you're done type of thing, which is nice. In terms of, you're calculating it in terms of h naught, v naught, theta, and g. Those can be in your solution. That's it.
Is it really though? I don't
Listen to Central.
Bless you.
It's fine.
That's what we're also resolved. Did it work? Yeah. Give me extra credit. For what?
Anyone need more time with this? Raise your hand. You need more time? Okay. All right.
So you don't use They say in terms of something, then that variable should be
Use beta. I think what's the figure out? Do you use x minus x naught?
Oh, what?
So that's not like
Trying to find the vertical height.
yeah.
So we're just going to combine all. I know. So we got one through.
I plugged it in negative 0. And then it's like, I'm gonna just do it the way it is.
It's not as why not?
You're talking about yes.
Oh yeah. Oh, you cube would be the
All right. What equation would be best to use, Kevin? Alpha. Yeah, alpha. I agree. So we could go dy equals b naught y plus ay 2ay squared.
So it's like in the future.
Not let's see, 2ay and then y minus y naught. So okay. Oh, what's the final velocity along y? Zip. Nothing. So we got 0 equals v naught y squared plus 2ay y minus y naught. And then I can subtract both sides by v naught y. It's going to give me negative v naught y squared equals negative 2g, because that's what ay is g, right? Negative g. And then I could plug in y minus y naught. So the negatives cancel out. You can see, divide both sides by 2g. I get v naught y squared over 2g equals y minus y naught. What's the last thing I'm going to do? Add y naught to both sides. So it's going to be v naught y squared over 2g plus y naught equals y. And there we go. So once I get all, once I measure all my information, I can then just plug that in and get that. Okay. Now to get x.
Wait, do you want to put a sign? Say it's sign.
Oh, thank you. Yep. I do want to put that in there. So v naught y is v naught sine theta squared. So there we go. There's that. Sure, that sounds good.
Just on the top of the highest thing. So the v naught times is like
Got it? We good? Okay. So we got that. So next up, I want to talk a little bit before we attack this for calculating the position, the horizontal position. Say that again. We gotta find time, right? I can't just outright calculate the horizontal position here because I'm gonna need the time. And who dictates the time? Does the horizontal dictate the time or does the vertical? The vertical is the thing that dictates the time. So depending on basically how big the acceleration due to gravity is, that's gonna tell you when it's gonna hit the ground. So use something in the vertical to find out how long it takes to reach that point. And once you got that, then you can calculate that. So go ahead, I'll give you a little bit of time, see if you can figure that out. Go.
Just assume you have to.
You all right?
Come on, Juan.
All right.
Don't scratch the other
So, the best equation to
Yeah,
find
once you got the time and
the
calculator,
best equation to find distance, beta along x, and the best equation to find velocity. Right?
I remember you using this in terms of.
I wanted this class, I'm like, oh my god. I felt consumed, dude. I was so lost.
You got time? What about now position? Final. So guys, once you got the time, calculate the position along x. The final position along x. Correct. Yeah.
This next b, no, this is b equals x horizontal.
Right. Yeah. But with a projectile, dx is always the same. So that's why we just call it dx instead of d on x.
There's no acceleration.
At any other moment, yeah, it's gonna be.
like that it takes like 5 minutes.
Well, we put in negative g so that in our solution, I know I'm just gonna plug in positive g now. Yeah. Because yeah, so I just plug in now after once I'm done. Because it's going a little bit to the right and a little bit up. So the magnitude is all here. And how would you do that? You know, I don't know how to, because what if it was an angle like slightly up? Then it would be different, everything would be different. Correct. What we basically do is we break it up into horizontal and vertical parts, because we know how to calculate those. That's just one-dimensional stuff that we've done before. So that's what you do, and then you combine them back together whenever you. So you're splitting it apart, solving the problem, and then depending on what you need, you combine things back together in the end.
Would there be like a question where we're given the magnitude and then we're asked, given magnitude and asked for more?
Yeah.
If you know everything, I'm going to give an extra
Well, you would need the angle as well.
Oh, no, to find the vector.
Yeah.
Oh my god, my head.
But I've done that before with these, and we're going to do something slightly more difficult. Oh, what? Dude, that fuck's going to be huge next time.
Oh yeah.
You have to be the. Everyone's gonna want Also, I really. Yeah, I know it does. You're repeating the whole thing.
Oh shit! I saw the slide.
Oh no, I'm right.
Anybody need more time on this? Raise your hand. Need more time? Calculating.
Oh yeah. Don't worry, we're not that low.
So at first we're going to need to find the time, right? What would be the best equation to find the time? Omega. Definitely omega. Yeah, that's going to be the easier one.
We can use the other one though.
So Vy equals V naught y plus AYT. I know my final velocity along y is nada, right? So we got 0 equals v naught y is v naught sine theta, and then ay is negative baby g times time. So we can find out the time because it's just going to be v naught sine theta divided by g. Those negatives are going to cancel out, right? Or not even cancel. You could just add. There we go. So we got that. But that ain't our solution because we're going to need what? What then are we also going to need to calculate the position along the horizontal? So I'm trying to call it gamma. We'll see if it sticks. Maybe not. Gonna see if fetch works too. So initial position times time. There we go. So okay, initial position is just 0 along x. So that means we got the final position is 0 times the x component of the velocity. So that's v naught cosine theta multiplied by the time, which is v naught sine theta over g. So the final position along x is going to be, just to simplify a little bit here, v naught squared sine of theta cosine theta divided by g. I'm sure there's a trig identity in there somewhere, but yeah, I got what I need, so yeah, screw it. Notice how cool this is, though. So, especially something like this, in terms of solving variably. If I made this speed faster, what would I expect about the position as to where I would have? If the faster that goes, would I need to go further away to reach the peak, or would I need to go closer to reach the peak? I need to go further away, right? Intuitively, we kind of know that. But what's nice is the math is justifying it for us. It's saying the faster the speed, the further you got to go to find out where that is. Or what if we did this on a different planet like Jupiter, where the acceleration due to gravity is super big, is much bigger, right? So if we did that, would you expect it to be a shorter distance or a greater distance? Shorter distance. We'd have to get shorter because it's going to fall faster. And so sure enough, if this gets bigger, if the acceleration due to gravity gets bigger, this gets weaker, or that gets smaller. So you can get what's nice about solving these things variably is you get a sense of, and over time you're going to be able to do things like that. Gives you a sense of the physics of the situation of what's going on. Okay, great. So, and you get similar things with Vy. Notice they both have that. So what I would like you to do, let's see. Here you go.
Wow, Kevin.
76?
Can we get 54 likes?
76? Okay. All right. So 76 what?
Meters.
So the height, 76 centimeters. However, we want to measure